Okay, we are now recording chapter 4.4, L'Hopital's rule. So way back when we did limits, I had mentioned that you would in fact be seeing limits again. And this is actually not the last time that you will see limits. But anyways, in this case, we're going to talk about using what's called the L'Hopital's rule in order to evaluate these kinds of limits. Uh, we are going to focus in on the two main indeterminate forms. Now, there are several others listed in the book, but we're going to focus on these main two forms. First one is infinity over infinity, and the second one is 0 over 0. So when evaluating a limit of a function f of x, and you end up with either infinity over infinity or 0 over 0 when you evaluate the numerator and the denominator by themselves, then you can apply L'Hopital's rule. And as long as you end up with one of these two indeterminate forms, you can continue to apply L'Hopital's rule. So what does L'Hopital's rule say? Well, if you end up with one of these two indeterminate forms, you can take the derivative of the numerator and the derivative of the denominator, and then try to take that limit again. Now, you may end up with a limit that you can't determine, but as long as you can, the use of L'Hopital's rule will allow you to evaluate these kinds of functions. So I'm going to look at a couple examples. So I'm going to erase this. And let's take a look at an example of each one of these. And then we can move on. Now, again, I mentioned this for those of you who actually watch these recordings, that I'm going to stick to the two main forms, indeterminate forms for L'Hopital's rule, although there are several other variants of it. So let's take a look at this one. Let's take a look at the limit as x approaches infinity of x divided by it's 2x over 3e to the x. All right, let me show you this. So the limit as x approaches infinity of 2x over 3e to the x. And yes, I'm choosing a very simple example here. Now, by themselves, the limit of 2x, which is unbounded, is infinity. And the limit of 3e to the x, again, because it's unbounded, is also infinity. So this falls into the category of infinity over infinity. So I can apply L'Hopital's rule. I can take the limit of the I can take the derivative of the numerator and the denominator by themselves. Do not take the derivative by quotient rule of the entire thing. Many students make that mistake. Take the derivative of the numerator and the denominator separately. So this leaves us then with the limit as x approaches infinity of 2 over 3e to the x. Now, this is no longer infinity over infinity. It's 2 over 3e to the x. The numerator is a constant. Okay. So if we want to be completely technical about this, I'm going to pull this fraction out in front of the limit. Again, this is being completely technically correct on this. So I have 2/3 times the limit as x approaches infinity of 1 over e to the x. Now, again, you're going to have to know the nature of the beast here. E to the x, as x goes to infinity, is unbounded. Okay? So 1 over e to the x is going to be 1 over infinity, and 1 over infinity is equal to 0. So that limit is going to 0. What does that mean? Well, that means that 2/3 times 0, of course, is equal to 0. So we have 2/3 times 0 is equal to 0. So the original limit was the limit as x approaches infinity of 2x over 3e to the x. It turns out to be one of our indeterminate forms. In applying L'Hopital's rule once, we end up with 2/3 times 0, which is equal to 0. That means that if you take a look at this original function, 2x over 3e to the x, you will see that the x-axis is a horizontal asymptote as the function goes to infinity. Okay? All right, first example then. And by the way, if you're asked to evaluate a limit by using L'Hopital's rule, you're expected to use L'Hopital's rule, not just say that I know this is going to 0. All right. If you don't show that you've used L'Hopital's rule, it's wrong. All right, let's take a look at a second example then. All right, so let's take a look at the limit as x approaches 0 of x over e to the x minus 1. Now, when we evaluate these limits individually, of course, the limit of the numerator is 0, and the limit of the denominator is also 0. So this is our second main or major indeterminate form, 0 over 0. So because it's 0 over 0, we can apply L'Hopital's rule, which says that we can take the derivative of the numerator and the derivative of the denominator by itself. Okay. So we have then the limit as x approaches 0 of 1 over e to the x. All right, so we end up with, by taking the derivative, we end up with the limit as x approaches 0 of 1 over e to the x. This is no longer in a determinate form. We can evaluate 1 over e to the x by substituting x equals 0. So I have 1 over e to the 0, which is 1 over 1, which is equal to 1. So that means that the limit of this function is equal to 1. As x approaches 0, the function is approaching 1. And that is an example of our second major indeterminate form. Again, we'll only concentrate on these two forms, although when you look in the textbook, you're going to see that there are several other forms, alternate forms, that can use L'Hopital's rule. But I'm going to focus in on these two only. So these are the only two that you're responsible for. All right, so this takes us up to chapter 4.4. It's Monday morning. I will probably try to get a few more done in this chapter today. And certainly by tomorrow, I should have the rest of the chapter done. Okay, guys.